Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 451. Lexicographically smallest string after JSON removals whenever it wants to show up on screen. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. I don't think this one was too tricky, but it is a little bit annoying, for sure. And honestly, I'm not quite sure about the complexity. I think, I know about the complexity, but I'm not quite sure why it runs fast enough. Maybe it is just, maybe I'm a little bit lucky. I don't know. Let's take a look real quick, actually. But honestly, for me, it is a dynamic programming problem, and as such, it is just a problem in which I am trying. 9 seconds actually not great, but and we'll see. Maybe we can optimize it a little bit. But yeah, it's just honestly for me, it felt like I was just trying to brute force it as much as possible. Let's see. I want to see how long I took on this one actually. So I end up taking about 25 minutes, 35 minutes on this one. So actually not that quick. But because I was trying different possibilities, okay. But yeah, I mean, this is going to be a lot of DP, both DP, but we'll go over two DP. I did DP in two ways, but we'll go over them well quickly, right? Here, all right. Let me bring up the drawing things real quick when it wants to load. Sorry, technology. Who knows how technology works? Okay, there we go. I mean, well, I have to put it on the screen. The core idea here is just in a way brute force. It's honestly the way how I think about it, and if you watch me solve it live, that's basically the way that I kind of extend it. I just tried a different way of brute forcing. I did come up with another solution, which we won't go over, but the idea there is that I was trying to do divide and conquer. So initially, so let's say I have, I don't know, some array, and honestly I was just trying to do the divide and conquer DP, where basically you break it into this part and or you do a loop, right, where you break it into, like, say this part and then this part, and then you try that, and then you do, and then so forth, right, dot dot dot, right, and then all the way. So something like that. But it turns out that that's not actually good enough, because there's a case in which the lexicographically smallest part, it doesn't give you the right answer, because it's just like what's lexicographically smallest for this part and this part in combination does not give you the smallest overall. So that's really that's the idea of why it doesn't work, even though I tried, right? Okay, but the core, but the idea here is that, okay, so let's say you have a string of length, something like this. I'm too lazy to write out the string, so you can just imagine some characters to go with it. But then the idea I have is that, okay, so that means that here we have a couple of ideas, right? That means that from the beginning, so I did it within another loop in this way before. So, okay, well, if we can skip the prefix, then what does that mean? That means that we can get rid of the prefix, and then we just take the answer for the rest, right? And that's it. That's my loop. My first loop is just, checking brute force in a way. If we get rid of no characters, so we use one character, the first character, and then the rest, or can we remove the first character? Well, you can, because you can remove one character, but let's say you remove two characters. If you could remove them, then now it's just a recursion on the rest, right? And so forth. And then three, technically four, I guess, because three you can't remove either. And then dot dot dot. So that's basically the core idea behind this part, and we'll go back to the code real quick. And that's the core idea behind this part, right? Is that I go, okay, so what if we remove no characters, because, I don't know, we just can't. So then that means that we take the first character, and then we just do a recursion on the rest. Remember, we cannot remove this. So it's not that we cannot remove it, but what happens if we don't remove it, right? So that's just my default case, and this will give us a string, right? Yeah, and then otherwise for the right side, we go, okay, well, let's say if it's possible to remove between index and right inclusively, then now we can remove that and then we just have a suffix. So that's basically how I set it up. And this will give me a string, right? And if the string is lexicographically smallest than the best, and this is actually in Python pretty easy to do. I think I guess in most languages there's a string compare, so maybe it's not that bad anyway. But this is pretty easy, right? Yeah, if current is less than best, then we just update best to lexicographically smallest and we return the best. Let's go over the complexity really quick because I think this is something that it's a little bit uncommon, right? And what I mean by that is that, okay, so usually, time complexity is equal to the number of inputs times input or time per input, right? Which is time over input, and then input cancels out, so you have time, right? So index goes from 0 to n, right? So there's n inputs, and then each input takes O of n times, roughly speaking. I mean, this goes from index to n, so you can say it's n over 2, or like on average is n over 2, or n over n choose 2, etc. Something like that. You can do the math that way. But either way, it's going to be O of n squared, right? Time. A lot of the time, each input takes roughly speaking anyway. The reason why I say roughly is that it's a little bit awkward because this actually returns an n string character, and this is what I was going to get into. And then this comparison is also O of n, so it's kind of like n square-ish, but this is a very fast O of n, so that's why. So actually let me change that. So each input takes n squared time, so this is actually O of cubed time. But string operations are very fast, at least in Python. I don't know, maybe that's actually not a great way to teach it. Anyway, but in terms of space, it's the same idea. It takes O of n space, and so then this is O of n squared space. That's what I wanted to kind of point out really quick. Of course, this n cube is also, there's a lot of nuance, right? In the sense that this isn't always O of n, it's just worst case O of n, right? Because if you compare two string, if they differ in the first character, for example, then it's a very fast, etc., right? So that's basically one idea that I might mention, right? And I don't know, maybe you can do something smarter about it. Yeah, I mean, I don't know. Maybe there is, but for now, I don't know. It wasn't necessary. So then now we have to answer, okay, is it possible to remove index and right? So that's basically what leads us to the second dynamic programming. And actually, I don't know if all of this is actually necessary per se. I think I don't need this. I think when I wrote this, I actually didn't have this divide in the middle one. But yeah, this is for so okay, so let me actually write there. Go. So Go gives us why is my keyboard? Gives us the best, which is the lexicographic. How do you spell lexicographically smallest string? Keeping in mind that lexicographically smallest is a greedy construct, right? Meaning that, if this gives us the lexicographically smallest string, then combining it with itself is always going to be as small as possible, right? That's basically the idea, right? Because because if this is better than the rest, then it doesn't matter. But otherwise, you kind of want to define this like in a recursive kind of way. And of course, if we get to the end, then you return empty string. Anyway, and then P is it possible to remove all characters from left and right inclusive? And for this is a very dynamic programming thing, though I did get it wrong, so maybe it's not that standard. But yeah, if left is greater than right, and it can only be greater than right. It can only be greater than right. Maybe I do need this, but it's a little bit awkward the way that I set it up, actually. Yeah, I mean, yeah, I don't know. But yeah, if we have no characters left, keep in mind that this is inclusive. That's what this is saying. If they have no characters left, we return true. If they have odd number of characters, return false. Just to kind of, I guess you could also make sure that the input doesn't have it. And I just have this assert here just in case to say that we have two characters. And then now we can remove from the left, right? If the first two characters, then we remove it and recursion, right? And this is memorized. Remove it from the right, same thing. And this is actually a little bit wonky, is that it removes it from the left and the right at the tails. I think this one's the most important one because this is after. So this is saying that, and maybe I had them in the wrong order. I think it's more clear if you say we remove everything in the middle, and now you have the two left and the right left. Then now you combine them and then remove those to return true. Otherwise, though I think this way is a little bit faster in that this kind of optimizes it out, but you probably go through the entire thing anyway. And then this is just the divide and conquer of like, okay, if we split it up on the left side and the right side, can we remove the left side and the right side independently, right? And I forget what there's an input in which this is necessary. Otherwise, I wouldn't have it because I got a wrong answer from it. I forget what it is though. But yeah, but suffice to say, this is just divide and conquer. You just have an, if the left side is we possibly remove and the right side is possible, and return true. Otherwise, return false because everything is just done. And of course, the good function is just we're able to remove two characters in a row, which I have this for true, and then also if it's AZ or Z to A. Maybe I need to figure out a cleaner way to write it. It feels a little awkward, honestly, but yeah. So what's the complexity of this one? Well, left is going to be 0 to n. Right is going to be 0 to n. And so inputs is equal to n squared. And then each input takes O of n times in the worst case. So this is O of n cubed time. So yeah, so again, you see that this is n cubed, this is n cubed. So yeah, we're good. I mean, 250 is actually kind of, I don't know. It shouldn't be n cubable. These people are incompetent. I think, if you ask me, it becomes 15 million. I know that you can maybe do it by 6 or something like that, depending on how, whatever, and it becomes 2 million. But still, like too tight, honestly, right? No, I don't know. Let me know in the comments because you can look at this. This took like 9 seconds. How am I supposed to know 9 seconds is fast enough? I have nothing to test, right? So yeah, so it's a little bit of guessing and YOLO, and yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve it live in the contest now. Let's take a look at Q4. I mean, maybe we could have gone Q3 anyway, but Leetcode is just being silly. I don't know. Maybe not. All right. Let's see. And at this point, other people have gone it also in like 20 seconds. Lexicographically adjacent moves. Okay. After performing optimally lexicographically smallest. Okay. BCA. Okay. Why is this a 4-pointer? This contest ranking thing is weird. And also, supposedly it's a heart. I guess it's only mattered relatively, but it's still a little bit weird. Okay. This feels like a divide and conquer DP. Well, maybe not even because of the lexicographically smallest thing. Right. Can we brute force one character at a time? So A, can the rest be removed? Or what is the most that can be removed? And then we try. Can we try one character at a time? I'm just so annoyed at that Q4. I have 43 minutes left. Is there any reasonable people who subbed? We subbed in like 6 minutes, so maybe it's doable. Can I do one character at a time in NTP? That's what I'm trying to think. How would that work? So the stack would be the thing, but then we want to say, okay. Is there just stuff? Order of operation matters, right? Because we can, is it ABCD, something like that? Does the order of operation matter? We want to hold A. So we always want to remove more than not remove for the shortest length. So then now when we remove, no, that's not true. That's example 3, right? Then okay, if we ask the question, can we do empty string? No. Can we do A? Well, the answer is no. We remove. Right. Do we always want to yeah, because they always have to match with everyone, so okay, so okay. A, fine, and then now how do you do it? How do you check whether you can have an A at the beginning? You remove, but then is it just that you keep the A? No. I'll be way less frustrated if I did not get Q3 or if I got Q3. Can I convert this to something that is a little bit easier to do math on? is there a choice? I was gonna say you could get minimum length, but again, this is not. You can do. And then you have this like set A thing, so it may be worth giving up an A to get rid of a Z. Right? What is the idea? Okay, let's say we have a divide and conquer DP. What would that even look like? This is the time that DP that I'm really bad at actually, because you want the operation to be the last one, right? So how we go? Something like left, right, and then like something like I don't know. But and then what? And you just like return the characters? That's 250 square already, right? So that's already kind of, I mean, even if you divide it by 2 and maybe a little bit more, or divide by 6, I think is the, so like 2 million. I mean, okay, let's say we do have divide and conquer, and this is what it looks like. What would you even return? It's not a length thing. I do want to return the string, but that is just, and then just combine it. But that's too many states, too many things. I guess 250, too many merges, and well, I mean, I don't know what else I'm doing, so let's write it out. What am I writing? What's after Z? I always forget it. If it's like, is this after Z? I don't know. I guess I can just write something like right, and then this is already crazy expensive, and then you have like for J in range of length L, length R, min, if L of negative J minus 1, I think, is equal to R sub J, or not equal to, but they're like off by 1, which is also not like a cheap operation, but okay, fine. And for now, we'll just ignore the A and the Z thing, just because I can't even deal with it. Because this is already gonna be too slow, honestly. Then offset. So then you merge, and then now you have L all the way from negative offset. No. No, 0, negative 1. No, negative offset is. No, but 0 is weird, so. So that's how I would write it, and this is already too expensive, but at least it is an answer. Right. I hope so. Let's at least see if it works. Then we could maybe think about it a little bit more. Z. Time to have left 31 minutes. ZE is not better than CD. ZE. Why is that? Do I do the divide and conquer right? Oh, because this always has one character on the left and the right. So we actually also want, yeah, maybe just left. Maybe that's a better default value. It's just that we don't do anything. Okay, but it's not gonna be fast enough, obviously. But I mean, it's nice to know that it works. Times 250. I do wonder how long it takes. This should give me the max case, and this is wrong anyway because we don't even do the ZA thing. 5 seconds is actually not as bad as I thought it would be. It's not going to be fast enough, right? For just 3 test cases. Actually, that's still faster than what I thought it would be. I was expecting way more than that. Can I represent this better? I'm gonna just YOLO. I mean, this isn't gonna work, but I just want to get it in there because I don't know how to optimize this in half an hour anyway. So I do want to just get it in the system. As I tried, but how do I? Is there a way to even optimize this in a good way? Oh, this isn't even right, so that's good. I mean, that's actually I do not mean that sarcastically. Oh, because removing it is no, but. That's weird. Oh, no. Okay, I don't remove this. Okay, so that's good. In a way. That's actually surprising, actually. That is actually surprising. So I should remove that. I mean, maybe it's just some typo off by 1 or something. But like we do DC, is that wrong? No, right? So why is this wrong? CDDC, okay. Oh, then CE, that's a crazy one actually. Why is this wrong? Let's just print it. 07, okay. Do we ever even consider what's it called? S. I'm debugging things that don't even matter, but okay. So this, so how do you get it? So it should be zero 03. No, 02. Oh, 02 is wrong. Because then now, or not wrong, but just that it would not merge in the correct way. What if you have 5? 5 you have, so maybe that's why. It just doesn't get connected in the right way. Huh. I think this is wrong anyway, but that's I didn't expect it to be wrong like this, because you want to get rid of the DC, but there's no actually but I guess there's no way to do it in between. I thought it would be 0 to, because then it would be F CE if you combine that way, and that's why. Okay, wow. Okay, today I learned that this is actually not good enough. How would I do it? Okay, I mean, I think it's the one where you do the gaps, maybe. So then you do jumps, right? Okay, how would that look? Okay, so let's say you go index, and then you go, okay. I mean, yeah, it is what it is. I don't mind doing it. I guess it's just like something like that, and then go if there's gap, then we do this, right? Like if everything between can be empty, then we take this. Is that fast enough? Maybe, I don't know. So just takes idea. So if possible from index to right, then current is equal to go of right plus 1 maybe, something like, it's a structure something like this, and then if current is less than best, then best is, the structure is something like this. I don't know if this is right, but can I do it something like that? If it's possible from index to right, and this is from index, of course, inclusively, then yeah, then we can go to the next one. Okay, and that's the substring, so that's the best, get the best possible substring maybe. And then now maybe possible of left right, if right minus left plus 1 odd 2 0 0, then we just return 0. Oh, return false because it, oh, because that means that we have odd number of characters. Otherwise we go, is greedy always the way to do it? Here maybe we want to cache anyway. It's greedy. I guess we'll try it. Why not? I have no ideas and I have 22 minutes left. So yeah, so stack. I rewrote this code, so why not? Nope, not that one. Okay, I guess this. I don't know. I guess I don't really need to copy this part, but. Something like that, I suppose. No. I think I like the way that I had it before, where I had it like. Does that work? Current is equal to. Okay, so this is still wrong. In fact, it is wrong for everything, other than the most breaks say wrong. Why is that? Oh, okay, so there's this. I guess that's not the worst. Okay, that is possibly worst case. But also maybe s of index plus go of index plus 1. Maybe that's actually more accurate. But of course, then we need if index, and then we just right? Come on, Harry. Base case A, BA is definitely not right. This is right. This is right. This is right. This is right. Why is BA not right? So it tries to go B and then goes skip to A. So why does it not try to remove all of them? I guess I don't have one that tries to go through all of them. No, I mean, if it goes from 0 to 4, so maybe I just need this to be plus 1, and because I suck at math. No, Right, it's going to be all the way to. Yeah, no, it's inclusive, so that's fine. Why don't I go from 0 to n minus 1, right? So, okay, so 0, 3, right? Oh, give me an exception. Oh, it doesn't give me an exception for some reason. But okay, so this gives me force. Why? I mean, that's probably true. Is this one? COD gives me, no. COD gives me DA. Oh, because B, Oh, so the order does matter, so I can't greet it like this. Okay, that's fine, maybe. Okay, so we just have to figure out that way. How do I fix this then? That's still true, that is, it's false. Otherwise, then now maybe it's a DP thing. What would that DP look like for this one? It's that. It's okay, so there's only 3 cases of making it smaller, so it's the top, this, and then also recursively everything, right? So maybe it's something like, yeah, okay, so then if left is greater than right, then we return true. Then we have no more characters, right? Because it's inclusive. Otherwise, then now we go if good s sub left plus 1, assuming that this has at least 2 characters, right? Is that true? Right, let's assert that right minus left is greater than you go to 1. Okay. So if this is good, and p of left plus 2, then we return true. If good of s of right minus 1, and p of, oh, this is left plus 2, right? Left, right minus 2, also return true. Otherwise, then return just if good of, so this is the, if it is just everything in between is good, then this is the last move, right? Yeah, left plus 1, right minus 1, and return true. Otherwise, return false. Something like that, and that's like n cube, I suppose. Is that good enough? Nope. Left plus 1 is our range. Why? Where? Line 20. Left plus 1 is our range, but right is, what is the last one where that works? 2 and 3 for what? For S. Oh, it's because I have this thing. I forgot. Okay. Is that right? Is this even fast enough? A, okay. B, C, D, A. I think I remove everything, right? Z, D, C, E. This is right. This is right. Let's give it a YOLO submit. Actually, I mean, I should give a YOLO submit anyway because I have no idea. But we can also just try, was it 250? I just want to see the running time. Yeah, that's actually not that bad. So let's, well, I mean, I don't know if that's a good case actually, because you don't remove anything, but I'm going to YOLO submit anyway. Oof, ooh, I was wrong. That's not great. I mean, you can remove this, this, and this and get a P. No, that's not good. But you can remove, I guess because I never removed the first character. So this, the DP is a little bit wrong. Maybe this is right. DP is a little bit wrong though, because we never remove characters that we retain here. But that should be part of this. I don't know which M it wants to be, but that's weird. I don't know how to debug this easily. This should skip to the right P, right M rather, if it is possible to. Is it fast at least? Yeah, it's pretty fast. It's pretty fast at being wrong. Is it just this? Can all this be? Like, can that be removed? No. M and N O, right? N O. So why is this not removable? Well, so I don't think this is wrong actually, but this is wrong. Am I missing a case? So okay, so the last one, this. So you take this, right? Is there other cases? Oh, divide and conquer, the one in the middle, huh? Because then now you're divided into two. Okay, fine. That makes sense actually. Okay, fine. Right. I plus 1. Right. So someone like that. Okay, okay. Is it fast enough? It looks okay, fast enough. YOLO submit. If it times out, then I'll be a little bit sad. But maybe we're closer than before. Yeah. Okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to get mental health. I'll see y'all later and take care. Bye-bye.